The year was 1985. The Hubble Space Telescope was still 5 years away from launching on a space shuttle. Although nervous, the scientific community was excited. Hubble would revolutionize the way we saw the universe. But Riccardo Giacconi, the then director of the Space Telescope Science Institute, told his team that they should start thinking what would come after Hubble, much further down the road. His team protested, saying that they have more than enough to do with Hubble. But Giacconi was insistent, and so, his team got to work, drawing up concept ideas for what was then known as the Next Generation Space Telescope. Today, the NGST is a superstar, and one of its kind. Today it is called the James Webb Space Telescope. The need for a new telescope arose in 1995, when astronomers pointed Hubble at a seemingly empty patch of the sky for 10 consecutive days. Many experts predicted the extended observation would be a waste of resources, revealing at best a handful of dim galaxies, but instead the effort was richly rewarded. The resulting image, the Hubble Deep Field, showed that the empty spot was actually filled with galaxies by the thousands, stretching back 12 billion years into the 13.8 billion year history of our universe. There were galaxies everywhere. The Hubble Deep Field showed that the early universe was even more crowded and exciting than most anyone had expected, offering observational treasures to the scientific community. Yet, impressive as Hubble's deep field was, astronomers wanted more. And after more than 2 decades of labor, the James Webb Space Telescope finally launched on Christmas Day 2021. By July 2022, the telescope had reached its deep space destination, and its instruments had been put through their paces, and shortly after, its long-awaited first year of science observations began. And although scientists expected to see the unexpected, no one had the slightest clue the birth of the universe as we believe might be faulty and wide off the mark. Welcome to Lab 360, it's time to explore. Alright, story time. Rohan Naidu was sitting at home when he found a galaxy that nearly broke cosmology. As his algorithm dug through early images from the James Webb Space Telescope, Naidu shot to attention. It had sifted out an object that, on closer inspection, was inexplicably massive and dated back to just 300 million years after the Big Bang, older than any galaxy ever seen before. At that moment, Rohan knew that it might be the most distant starlight we had ever seen. Days later, he published a paper on the candidate galaxy, which was named Glass Z13, and the internet exploded. The extraordinary discovery of this galaxy, just weeks into Webb's full operations, was beyond astronomers' wildest dreams. The cosmic dawn now started to look like a bright cosmic afternoon. In the weeks and months following Webb's findings of surprisingly early galaxies, blindsided theorists and observers have been scrambling to explain them. Were these galaxies the first hints that the universe is stranger and more complex than even our boldest theories had supposed? At stake was nothing less than our very understanding of how the orderly universe we know emerged from primordial chaos. Hubble's record for the most distant known galaxy had been GN-Z11, spotted in 2015, at a redshift of 11, thanks to a 2009 upgrade to the telescope that enhanced its modest infrared capabilities. A redshift of 11 corresponds to a cosmic age of about 400 million years after the Big Bang, a point at the brink of when galaxy formation was thought to begin. Webb's early revelations could be poised to rewrite the opening chapters of cosmic history, which concern not only distant epochs and faraway galaxies, but also our own existence here, in the familiar Milky Way. You build these machines not to confirm the paradigm, but to break it, said JWST scientist Mark McCaffrian at the European Space Agency. You just don't know how it will break. As light from a very distant galaxy travels across the cosmic abyss, it is stretched by the expansion of the universe, a broadening of wavelengths known as redshift. The higher the redshift value, the more stretching the light has experienced, and thus the more distant its source galaxy will be. Redshifts for early galaxies are so high that their emitted visible light has stretched into infrared by the time it arrives at our telescopes. But with Glass Z13, at a redshift of 13, it is some 300 years after the Big Bang. Could galaxies form so early in the universe? Although more study is needed to be done on the emerging primordial candidates, scientists hypothesized that smaller galaxies could have formed early in the universe, and that might explain the likes of Glass Z13. Little did they know that Webb was just beginning to unearth the universe. In the following days, dozens of galaxy candidates from Surs and Glass sprung into view, with estimated redshifts as high as 20, just 180 million years after the Big Bang, some with disk-like structures that were not expected to manifest so early in cosmic history. And now, a discovery has been made unlike any other, and with it, the cracks in cosmology have started to appear. While scanning a region of the cosmos near the Big Dipper, a group of astronomers identified 6 faint objects as they appeared well over 13 billion years ago. They suspect the objects are ancient galaxies. Scientists expect such early collections of stars and swirling matter to be relatively small. After all, such galaxies hadn't had much time to form or grow. But these galaxies are giants. It's bananas because the objects, which are red and bright in the Webb observations, might host billions of stars similar to our Milky Way galaxy. These galaxies formed some 500 to 700 million years after the universe was created, during the Big Bang, and at such a time, there simply shouldn't have been enough matter around to create fantastic bursts of stars and solar system. The extremely distant galaxies are the fuzzy red objects as shown here. They're red because the universe is expanding, and the light traveling through it becomes stretched out, ultimately shifting to longer redder wavelengths. Importantly, the research about these galaxies is just the beginning. There is potential, for example, that some of these bright red masses are a different kind of primordial object, like a quasar, intensely hot, energetic matter, spinning around a black hole and emitting tremendous amounts of light into space. However, we aren't sure, just how we aren't sure about the many mysteries of the universe. But one thing is for certain, the birth of the universe is now under intense scrutiny, and whatever comes out of Webb data, I hope we use them to form a better origin story of the universe, because what is science without constant upgrades and understanding? What do you guys have to say? Drop in your comments to let us know, and don't forget to subscribe to Lab 360, because together, we will explore.